Assalamualaikum warahmatullahi wabarakatuh. Okay, today we will talk about data structures and CAATTs for data extraction. Here me, Surya Patra, Abdilah, and my friend Andi Ramaadhan. At the first section, we talk about the data structures. Data structures fundamental component. It consists of two methods, which is the first is organizational here, and the second is access method. The organizational is the way records and physically arranged on the secondary storage device. So here physically it means maybe it's more uh, relevant about the flat file. To organize it maybe in sequential or in random. And then the second is the access method. It is the technique used to first is locate records and to navigate through the database or file. The data structure approach, it consists of 6 approaches. The first is the flat files structures, and then index structures, hashing structures, pointer structures, hierarchy and network database structures, and the relational database structure. So it is the only database here. The first is flat file structures. Flat file model describes an environment in which individual data files are not integrated with other files. Data processing is thus performed by standalone application rather than integrated system. The flat file structure here, it's maybe in sequential structure or in random structure. If it is just the sequential structure, sequential files are simple and easy to process. The application starts at the beginning of the file and process its record in sequence. So it is sequence like this. We can see that the key here are in sequence. 1874 and then continue to 5 and then to 6. The records are read sequentially. It is a good example. Okay. The next is index structure. An index structure is so named because there exists a separate index that is itself a file of record addresses. The data file itself may be organized either sequentially or randomly. Records in index random file are dispersed throughout a disk without regard for their physical proximity to other related records. If we use the index structure, it's use advantage and disadvantage. The principal advantage of index is in operation involving the processing of individual records. Another advantage in their efficient use of disk storage. So it's more efficient in the use of the storage. And then, but it has disadvantage. The advantage for the random files, if we use the index structure, is that it is not efficient structure for operation that involve processing a large portion of a file. So if we must face the large portion of file, we can use the we can use the virtual storage access method or VSEM. It is the figure for the index random file structure. So here the index and here the physical disk storage device. The index is organized randomly. What was exists in the physical disk, like here the key value is for example 1876, and it is not sequential with the next key value. It is 1900. 86. So it is random, and then when we find the data at the physical disk, we can see at the key value, and then its contents of record address. So it is about the disk. The disk is maybe in a form of like this, like cylinder, surface, or records, or maybe in a number like this. Okay, the next is hashing structure. Hashing structure employs an algorithm that converts the primary key of a record directly into a storage address. So hashing eliminates the need for a separate index. We can see here the index is not separated, but when we use hashing structure, we use a calculation, something like that. Hashing, we call it hashing techniques. For example, when we try to find the file number that identified as 15943, then it is first we find about the prime hash, and then we divide it by the key, and we got something like this numbers, and then it can be defined into something like this: cylinder, surface, and then records. To find here 15943 to the disk. Of course, it has advantage and disadvantage. The advantage, the first is the access speed. Calculating a record's address is faster than searching for it through an index. But the hashing structure have two disadvantages. The first is this technique doesn't use storage space efficiently, and then the second is the reverse of the first. Different records key may generate the same or similar residual, which translates into the same address. This is called a collision because the record cannot be stored at the same location. So like this, when lack because of lack of something, not like maybe file have same location, so the collision, that is the collision pointer, it is make a new place for the same key value but in different space. So the next is the pointer structures. The pointer structures approach stores in a field of one record the address or pointer of a related record. The pointers provided here connect between the records in different disks. Pointers may also be used to link records between files. There is three types of pointer. It may be in physical address, relative address, and logical address. Physical address pointer contains the actual disk storage, and then the relative address pointer contains the relative position of a record in the file, and then the logical key pointer contains the primary key of the related record. This key value is then converted into the record's physical address by a hashing algorithm. So it is the type of pointers figure we can see here. The first is physical address pointer. It is for example, we find the record 1 at a different record place. It is in a different disk, and then the relative address here, and then the logical key pointer. Okay. Okay, the next is hierarchical and network database structures. Hierarchical and network database models employ many of the preceding flat file techniques, as well as new proprietary database structures. A major difference between the two approaches is the degree of the process integration and data sharing that can be achieved. Link files may also contain counting data, of course. Here is the figure. A link file in a many-to-many relationship. So it is very useful for when we have so many relationship. For example, the first vendor have 1, 2, 3. Have 3 product, and we bought all of that, and then this is the link. You use arrow here, something like that. Okay, the next is relational database structure. Relational database are based on the index sequential file structure. Multiple index can be used to create a cross-reference called an inverted list, which allow even more flexible access to data. Now, we can see at the figure 8.10 here. The inverted list here is the employee table, and then it is 2 index here, MP num index, and then YTD earnings index. Multiple index can be used, yes, like this. The key value here also, any key value, yeah, something like that. So it is become the invert this. We continue to the relational database theory. The formal model has its foundations in relational algebra and set theory. A system is relational if it is the first represent data in the form of two-dimensional tables, and then the second supports the relational algebra's function of restrict, project, and join. Okay. Okay, continue. Now, this relational data concept for the first, we have some materials about entity, occurrence, and attributes. What is that? Let's we talk about it. The first is entity. An entity is anything about which the organization wish to capture data. So it is maybe in physical or in conceptual. For example, and the entity is maybe like, for if I say physical, like maybe inventory, or maybe about personal, I mean worker, yeah. And then, or maybe in conceptual, like something that we can't see, like maybe account receivable or account payable, something like that, yeah. And then the next is occurrence. Okay, where is the occurrence? Yeah. The term occurrence is used to describe the number of instances or records that pertain to a specific entity. So the occurrence unit means that this is how many time the entity occurred. For example, like when we talk about personnel, maybe there is in the company we have 100 personnel, so the occurrence of the entity of personnel is 100. Simple, right? Yeah. And then the next is attributes. The attributes define it is define the entity in detail. We will talk about it later. Pokoknya it is, yeah, it is define something like for example, we back to the previous example, we talk about personal. Maybe our worker, where they who is their name, or maybe where they live, something, yeah, like detailed it for information, something like that. And then the next is association. The association the association the association is represented with a verb such as ships, request, or receive. The labeled line connecting two entities in a data model describe the nature of the association between them. So, for example, one entity with another entity, uh, something that connecting them, it's we call it association. As simple as that, in a simple example, of course. And then the cardinality. This is maybe I can say that it is the opposite of the association, because it is talk about the difference between each entities that associated. Now here is the figure that give us example of entity associations. Association and cardinality. The cardinality we can see at this number, maybe 1 1 1 1 with 1 1 with m, 1 with m, and with m. Here it means that, for example, employee and company card. For example, every employee, we talk about something like maybe sales staff. Every sales staff we give them like motorcycle one, or sorry, company card, yeah. One employee, one company card. Every employee get one company card, so it is one by one. Like another example, one manager got one laptop, so it is one by one, like something like that. Then here, for example, vendor. For vendor, for example, one vendor can the company only have one vendor that it provide all of our inventory, so it's one vendor with many M for many inventory. Or maybe one vendor have so many inventory, and our inventory it consists of many vendor also too, so it is many vendor and many inventory, something like that. Okay, the next is the physical database tables. Physical database tables are constructed from the data model, with each entity in the model being transformed into a separate physical table. Properly designed tables possess the following four characteristics. The first is here: the value of at least one attribute in each occurrence must be unique, so it must be different for each occurrence. And then all attribute values in any column must be of the same class, and then each column in a given table must be uniquely named. The names must be unique, must be different for each name. And then tables must conform to the rules of normalization. About the normalization, we will talk about it next. Okay, the next is about the linkage between relational tables. The relational tables can be linked through this theory. Logically related tables need to be physically connected to achieve the association described in the data model. For connecting it, we use the foreign keys in the key to connecting one table to another. For example, like this. Linkage between relational tables. Okay, for example, here, when we see at the customer table and then sales invoice table, cash receipt table, line item, here of course, all of it is will be connected each other when we audit one of them. When we especially the cash receipt and the sales invoice. Okay, the first is for example like this. Customer number 18758, we take it from will at the cash receipt. Oh, where is and then in the sales invoice we see here, so we can see the amount and the ship date, and then the amount is the same with amount received at the cash receipt, and then yeah, something like this. The linkage is represented at the arrow here at the strip line. Okay, next. This is user views. User view is the set of data that a particular user sees. The user can view in a form of physical or digital. So it is maybe in a paper base or maybe in a digital base. Like maybe in our screen here, example of user views are computer screens. Okay, and then we talk about database anomalies. Anomalies here means such table exhibit negative operation symptoms. So something that like maybe when we do any command or order, it cannot do what we order because of maybe we will talk at the next slide. We just need to see here. For example, it is the normal one. This is the unnormalized database table. We can see here it is for the same description. It is there are one rows. Okay, next. It is types of anomaly. The first is update anomaly, insertion anomaly, and deletion anomaly. Update anomaly result from data redundancy in an unnormalized table. For example, like this. We see that here for the same supplier number 22, 22, 22, it maybe have something that we need to update about the information, maybe at the address or maybe at the telephone number. So when we want to update the data, we must update all, or I mean each of the same supply number 22 omset sub. So each of this supplier must be edited or must be updated. And then the next is insertion anomaly. To demonstrate the effect of the insertion anomaly, assume that a new vendor has entered the marketplace. The organization doesn't yet purchase from the vendor because the company not yet have experience in purchasing to the new vendor. We cannot insert the new vendor to our database. So yeah, we want to add that as maybe one day we want to buy, but since or yeah, since we have no experience in purchasing from that vendor, we cannot insert it to our list. And then the deletion anomaly. The deletion anomaly involves the unintentional deletion of data from a table. So something like this. We can see the normal one. For example, here we have husband sub or supplier number 22 3 here, and then when this husband is no longer uh, sell their bracket to our company, we cannot as easy as that to delete the husband sub directly, because it contains of another part of our produk, bahan baku produk apa ya? Bahan baku produk. Okay, the next, we have talked about this. Okay, next, normalizing and linking normalized table. The first is normalization process. It involves identifying and removing structural dependencies from the tables under review. Types of the dependencies may be in repeating groups or partial dependencies, or maybe transitive dependency. Okay, the resulting tables will then meet the two conditions below. All non-key attributes in the table are dependent on the primary key. All non-key attributes are independent of the other non-key attributes. Yeah, it is the condition. Okay, we can see here it is the normalized database tables. Here, it's complicated. To help us, we use the link table here. So here, the first row is in here. Okay, it is, for example, the parts number and describe is bracket, cascade, breeze. It is transferred to the part or supplier link table here with the supplier number, part number 1, 22, 24, 27, and here we will transfer to the supplier table. Here is 22, 24, 27. Yeah, we can see the lesson. So it is become something like this. It is already categorized something like this. Part number 1, that is the bracket. The supplier, it's maybe number 22, 24, 27, or Osman, Bull, BNR. Yeah, something like that. Okay, the last is auditors and data normalization. Actually, database normalization is a technical method that is usually the responsibility of the systems professionals, but it has implication for the internal control. So the auditor should have an understanding of the process and be able to determine whether a table is properly normalized or not. So if not, of course, our structured data, the auditor needs to know how the data are structured before he or she can extract data from tables to perform audit procedures. So because the data that we'll use to perform audit procedure is from the normalist one. So the auditor should know, is it the data is well normalized or not, something like that. Okay, thank you. That is for me, Surya, and the next part will be presented by my friend Andi. See you.